In this presentation, you will learn about the evolution of environmental design and understand the transition towards circular design. Why design is relevant? Every year, the site where Glastonbury Festival takes place ends up like this. Will this resonate with the ethos of the festival? I think Victor Papanek will say no. Victor Papanek was a designer and scholar on the field in the 1970s. He said, "There are professions more harmful than industrial design, but only a very few by creating whole new species of permanent garbage that clutter up the landscape and by choosing materials and processes that pollute the air we breathe, designers have become a dangerous breed. In this age of mass production, what everything must be planned and designed, design has become the most powerful tool with which man shapes his tools and environments, and by extension, society and himself. This demands high social and moral responsibility from the designer." Since the 1970s, little has changed. Design is still subject to the current system of take, make, dispose. 80% of environmental impacts of products are due to decisions made on the design stage. These decisions are made from selecting materials and manufacturing processes to dictating how a product would be used and disposed. Take, for example, durable goods as mobile phones. 90% of raw materials which go into making these goods became waste even before the product leaves the factory, and approximately 80% of what is made gets thrown away within the first 6 months of life. Another example is material selection. Take a mobile phone again. This can be made up from approximately 40 different elements from the periodic table, including copper in the wiring, iridium in the touchscreen, and gold in the circuit boards. Most of these precious raw materials end up in waste streams, and just 30% actually gets recovered. The argument relies on how designers can prioritize resource as value. Looking into the specific of products and their impacts, we need to understand the life cycle of a product. This diagram divides the life cycle into two sides: production and supply, which consist of material extraction, processing, manufacturing, transport, and consumption or demand, which consists of purchasing, use, and end of life. Through the life cycle of a product, there will be always inputs of energy and resources, and outputs of pollution and waste. The idea is how the decisions of the designer could minimize these inputs and outputs. As said before, about 80% of product lifecycle impacts are made in the concept development stage. After that, in the processing, manufacturing, and distribution in the last 10 years, impacts have been minimized due to advances in manufacturing processes and distribution, as well as advances in technology. However, major impacts happen also in the consumption side, especially in the use of products. Take, for example, a kettle and the energy consumed to boil water for a cup of tea. Finally, we need to think about the end of life of a product and if it is possible to ensure a second life for it. As a response to these various impacts, through time, there have been different approaches on how to minimize these impacts, as seen in the paper, A Conceptual Framework for Circular Design. But how from those concepts we started making a transition to circular design? The key is about thinking about systems change, considering the business model in which the product is being designed for, how that product will impact now but also in the future, making it part of a living system. How we could ensure multiple cycles, short and/or long, and not only with end of life in mind. And how can we consider value in a broader view, not as a price tag on a shelf, but also as an asset? How can we make failure a winning point if we allow to prototype with hands-on, focusing on experience, and how can we always keep the final user in mind? I'm not going to go much in detail on explaining this diagram, as it is something you should already understand from reading the paper. However, what I will do is to explain the taxonomy of design strategies with some examples. For design for circular supplies, an example I have is EcoVative. EcoVative produces a microfoam, which is a material that is used as packaging or insulator made of agricultural byproducts and a mushroom mycelium. This mushroom mycelium is a natural self-assembling glue. The material is made by combining a byproduct, for example cornstarch, with the mycelium in a matrix which can be formed into different shapes. The material is made indoors in a dark environment to become a solid biodegradable structure. And do you know Splosh? Splosh is a UK-based detergent manufacturer which sells sachets of a biodetergent. Their idea came from selling the formula of the detergent without the added water. Recently, they changed their presentation from sachets to bags as they received feedback from their customers that it was difficult to calculate how much water to put into the bottle when they received the sachet at home. The new presentation contains a concentrated formula that does not need to add extra water. Splosh goes beyond selling detergents as their business model consists on providing you with reusable containers. Also, they will send you the concentrate to your home every time you run out, as they sell their products just via their website. So, what does circular supplies mean for design? Some considerations of designing for circular supplies are fundamentally rethinking the feedstock and raw material of products, understanding of material physical and chemical properties, so there are opportunities for innovation, assessment of product durability and wear by use, understanding of logistics and distribution processes, use of renewable energy systems, consider user expectations of value, and also do an assessment of users' behavior. Moving on to design for resource conservation, an example is Elvis and Chris. For Elvis and Chris, design begins with a problem, which in this case was the amount of waste generated by fire hoses which were destined to landfill after their end of life. Just in London, 10 tons of fire hoses goes to landfill. The leather from fire hoses is a hard-wearing leather, which means it's quite durable. By reclaiming this material, they could upcycle it to make high-quality products such as handbags. They donate 50% of profits to projects and charities related to fire brigades. Another example is Deso, a carpet interior manufacturer. Deso provides carpets made of a biodegradable material from a corn byproduct. The carpet is designed in tiles to be easily replaced when damaged. Deso recovers the used tiles to be recycled. So, which are some considerations for design for resource conservation? So, you have to think about design for refurbishment and remanufacture. You have to understand of reverse logistics. You have to design to be made and made again. And it's important to understand users' expectations and perceptions of value. Moving on, I would like to talk about Braveform. Braveform is an example of design for multiple cycles. Watch this small clip to understand what it's all about. So, what does it mean to design for multiple cycles? Appreciation of users towards consumables versus high-end of products that last. We need to understand if all products need to be designed to last. It's also important to understand of service provision and how to design for services. We need to think about reverse logistics, remanufacture, and design for multiple cycles. Now, I would like to talk about design for long life use of products. Here, I present two examples of leasing garments. The first one is Mud Jeans. Mud Jeans is a denim brand born in the Netherlands. It is pioneering by delivering a leasing model for garments in order to ensure raw material supply. Older garments are made with 30% recycled content and 70% organic cotton. Customers pay a monthly fee for their garments. After 1 year, they have 3 options: swap their jeans for a new pair, continue leasing for another year with some benefits, and end the relationship by returning the garment to mud jeans. The second case is Armadillo Merino, a UK-based company who produces underlayer garments made of merino wool. We run a project with them to introduce their products to the Ministry of Defense by providing a leasing service. The rationale for this was the introduction cost of selling garments was too high, and this service could help the MOD to reduce inventory costs. So, what does it mean to design for long life use of products? This means that we need to understand of service provision and how to design for services. Also, understand on product wear by use. We need to design for durability and modular upgrade. Also, it's important to understand product failure and repair and possibility to remanufacture, and understand users' expectations and acceptance of these models. Finally, design for system change. Here, I present an example of a sharing platform. Sharing platforms could be business to business or business to consumer. Business to business sharing platforms have been very successful, and now we are looking to the same success with business to consumer models such as Airbnb and Uber. However, not all sharing platforms means that our use of resources will decrease. For example, some tourist cities such as Barcelona and Lisbon had declared that the housing market has gone up, partially thanks to Airbnb. New and old builds are being bought specifically not for living but for renting in these or similar platforms. However, other examples such as Flow could benefit companies and institutions by offering a unique sharing platform. Flow is a business-to-business sharing marketplace that enables companies to share their equipment and knowledge and skills of personnel that is currently underutilized. The platform is currently operational worldwide and is planning to expand. Imagine you have a piece of equipment that is not in full capacity. Why don't give access to this equipment with affordable rental prices to someone else? Another example of design for systems change is Bundles. Bundles is a Dutch company that offers clean clothes on a pay-per-wash basis. A Miele washing machine gets installed in your house with a bundle. Using the bundle and the Internet of Things, the company can monitor the usage of the washing machine. Like that, they can predict maintenance and refurbishment to preserve the product integrity for multiple cycles, as well as charge you for what you use. So, what does it mean to design for systems change? Basically, the designer has to think about the system rather than a single product. You have to consider the use of technology to change the system. Also, it's important to be creative and innovative to identify opportunities. You have to see if opportunities will be driven by a problem or by giving a solution. You have to understand user expectations and acceptance of these models. You have to think about developing partnerships and the implications for policy.